Welcome to Supervised Learning, one of the most powerful and widely used approaches in machine learning.
Supervised learning's tasks are well-defined and can be applied to a multitude of scenarios, like identifying spam or predicting precipitation. Supervised machine learning is built on 5 core concepts: data, model, training, evaluating, and inference. Data is the driving force of machine learning.
Data comes in the form of words and numbers stored in tables, or as the values of pixels and waveforms captured in images and audio files.
We store related data in datasets. For example, we might have a dataset of images of cats, housing prices, or weather information. Datasets are made up of individual examples. You can think of an example as analogous to a single row in a spreadsheet. Each example contains features and a label. Features are the input values the model uses to make a prediction. The label is the answer, the value we want the model to learn. In a weather model, the features could be latitude, longitude, temperature, humidity, cloud coverage, wind direction, and atmospheric pressure, while the label would be rainfall amount. In contrast, unlabeled examples contain features but no label. Once a model is trained, it predicts the label from the features alone.
A dataset is characterized by 2 things: its size, the number of examples, and its diversity, the range of values those examples cover. Good datasets are both large and highly diverse. A large number of examples covering a wide variety of use cases helps the model understand the underlying patterns. A large dataset with low diversity produces poor predictions on novel data that the model was never trained on. More rows do not fix a lack of variety. A small but highly diverse dataset also falls short. Most models cannot find reliable patterns in too few examples. Predictions will lack the confidence a larger dataset provides. And a small dataset with low diversity is the least suitable for machine learning. Without sufficient examples or variety, the model learns almost nothing useful.
For example, a dataset might contain 100 years of data, but only for July, useless for predicting January rainfall, or cover just a few years for every month, not enough to capture variability. A dataset is also characterized by its number of features. Some weather datasets might contain hundreds of features. Others might have only 3 or 4. Datasets with more features can help a model discover additional patterns, but more features don't always produce better predictions. Some features may have no causal relationship to the label at all.
In supervised learning, a model is a complex collection of numbers that defines the mathematical relationship from specific input feature patterns to specific output label values. The model does not come pre-programmed with these relationships. It discovers them through a process called training. Before a supervised model can make predictions, it must be trained. To train a model, we give it a dataset with labeled examples. The model's goal is to work out the best solution for predicting the labels from the features. Step 1. The model takes in a single labeled example and produces a prediction. For instance, it might predict 1.5 inches of rainfall. Step 2. The model compares its predicted value to the actual label. The difference, defined as loss, tells the model exactly how far off it was. Based on the loss, the model gradually updates its solution, nudging its prediction closer to the actual value of 0.75 inches. Step 3. The model repeats this process for each labeled example in the dataset, sometimes passing through the entire dataset multiple times. After processing every example, the model arrives at a solution that makes the best predictions on average. This gradual improvement is called convergence. This is also why large and diverse datasets produce a better model. The model has seen more data with a wider range of values, refining its understanding of the relationship between features and labels. During training, machine learning practitioners can also select which features the model uses. For example, they might add or remove time of day to see whether it improves predictions. We've learned a lot today, haven't we? Well, if you like this content, please like, share, and don't forget to follow for part 2.